Hi guys, all right, so here's day 4, techniques of differentiation. Okay, so I do have a challenge there for you guys to do. I know the work is already there, so you still could try and make sure you understand it. So the first one, I'm giving you an equation. I want you to find the average rate of change. So remember, average rate of change is just the slope of the secant line. It's just old school. I'm giving you the x values, right? The interval is 3 to 4. So you're just going to plug in 3 into the equation so you could get that partner for y. Then you plug in 4 into the equation, get your partner for 4, and then go ahead and do your slope formula. Okay, and then the new part, what we're doing in this unit is finding the instantaneous rate of change. Instantaneous rate of change is when you have one x value, you have 1 point, and we want to find it at 3. So if we want to find that instantaneous rate of change, we want to find the slope of the tangent line, so we're going to find the derivative. So we can use the power rule up here to find the derivative instead of doing the whole real definition, doing the difference quotient with taking the limit as h approaches 0. We don't need to do that. Okay, so how do we do the power rule again? You take the exponent, multiply it by the coefficient. So 2 times a half is 1, right? So here's my 1. Keep the base, and then decrease the power by 1. So decrease that power of 2 by 1. So 1x to the first is just x. And then this is my slope machine. So if I want to now find the slope at x equals 3, you just plug 3 in, and we get 3. Alrighty? Okay, so today, let's just review a little bit from yesterday. So the theorems that we learned. The derivative of a constant. So remember, a constant is something like y equals 2, y equals 3, right? It's just a horizontal line. Right, so if this was y equals 1 right here, and I want to find the slope of the tangent line, right, that's what the derivative is, it's just going to be 0. That has a slope of 0. So the derivative of a constant is always 0. So I wrote it out, f of x equals c, so therefore f prime of x, that's the derivative. Or I can say d over dx, which means the derivative of the function is equal to 0. So if I give you f of x equals 5, then the derivative is 0. The power rule yesterday, and the power rule is what I just did on part B on the challenge question, right? So if I give you f of x and I want to find the derivative, I take the exponent, multiply by the coefficient, that's where an comes from, keep the base, and decrease the power by 1. We can also write it in this notation, the derivative. D over dx, the derivative, is equal to as such. Okay, so let's just practice the power rule a little bit right here. Okay, my kitty cat is coming in front of the iPad. Hi, Petey. Come on. Okay. So if I give you f of x equals 4x to the 5th, here again is an example. I take my exponent, multiply by the coefficient, that's where the 20 comes from, keep the base, and decrease the power by 1. Okay, so a little review from yesterday. I think I'm just going to skip this part here. I don't want to get you all confused. It's just saying that you can find the derivative in pieces of each thing, but let's just skip that. Okay, so let's move in and just practice some of our own. So I give you a function. I want you to find the derivative. So 4 times 1 is 4. Keep the base, decrease the power by 1. Plus 2 times 1 is 2, decrease the power by 1. All right, so you guys want to try the next one? Pause it and then see if you get it right. Okay, I'm just going to write down here so I have more room. So we're going to get 24x to the 7th minus 10x to the 4th plus 6, and the derivative of a constant is 0, so we don't write it. Alrighty, looking good? Hopefully you guys got that right. Okay, so far we just took the derivative of just basic polynomial functions. Now we're going to take the derivative, and we'll look at it as an overview first, and then I'll show you the 2 theorems I'm going to do today with you. So today we're going to find the derivative where a function is written as the product of 2 binomials. Does everybody see that? Okay. Oh, it's the product of 2 binomials. And then we're also going to find the derivative when we have a rational function, so we have a division going on. So those will be our two that we do today. So they're just theorems that you do have to memorize, and you do have to know the product rule in order to do both of these as well. Okay, so here we go. So it says the product rule. So the derivative of the product, right, this is the product of two binomials, is equal to the first factor times the derivative of the second factor plus the second factor times the derivative of the first. All right, so how do I memorize it? I just say like first times derivative of the second plus second times the derivative of the first. Okay, and that's what this is right here too. You can see it, right? So the derivative is equal to, we could call this one the first, and we can call this one, so f of x will be the first, and g of x will be my second. So you can see it's the first times the derivative of the second plus the second times the derivative of the first. Okay, so when we're first doing it, this might be helpful for you to do that as well, like maybe call this the first and call this the second. All right, so let's give this a shot. So the derivative is the first times the derivative of the second. So 3 times 7 is 21, decrease the power by 1, plus the derivative of x is just 1, right? There's a 1 here, multiply, decrease the power by 1, plus, so we did first times derivative of the second. So everybody see what we did so far? We did first times derivative of the second. Now we're doing plus the second times derivative of the first. So 8x and then the derivative of a constant is just 0. So there's our derivative. Lots of times you can just leave it just like this, okay? So I think we are just going to leave it like this. You don't have to multiply it out if it was multiple choice and you didn't see it, but lots of times we just leave it like this. Okay, now let's do an example of the quotient rule. So I'm going to show you what the quotient rule is, and then I'll talk about what this purple is up top here. All right, so the quotient rule. So you can see now when we look at this question, it's a rational function, right? We have some division going on. So we can't use the product rule, and we can't use the power rule. So the quotient rule says the derivative of the quotient is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. All right, so that's like crazy. So you can look at this here, and then I'll show you how I memorize it. So we can call the top the numerator, we can call the bottom the denominator. And then here's what the rule is. The derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So you can use this if you want to. Or this is how I always had it memorized because it just sounds nice. It's easy to memorize. Bottom, so up here, I'm going to look at this now. Bottom d top minus top d bottom over bottom squared. That's what I memorized. So bottom d top minus top d bottom over bottom squared. And remember, d stands for derivative. Okay, so let's give this a try. All right, so the derivative is equal to. So use that little formula right there, or I'm going to say what I say. So bottom d top, so bottom times derivative of the top minus top times derivative of the bottom. And then all over bottom squared. Okay, and again, sometimes we'll FOIL this all out, but you know, lots of times in upper level, you can just leave it as such. So we're just going to leave it. Okay, I'll be happy if you're learning it. Okay, so that's the quotient rule. Excuse me. All right, now let's just mix everything up. We'll do just some straight up power rule. We'll do some product rule, quotient rule, and then I think we got some writing the equation of the tangent line in here too. All right, so here we go. So let's find the derivative. So the derivative is equal to, I can see I can just do the power rule. -2 times 3 is -6. Decrease the power by 1. So if I take -2 and decrease it by 1, I get -3. Remember, if this was multiple choice and you didn't see that answer, we could change this to -6 over x to the third, right? Negative exponents, we can move the exponents either direction just by changing their signs. Okay, next. Power rule again. So you're doing 2/3 times 8. So 2/3 times 8, right? That's what you're doing first. So we get 16/3. And now I have to decrease the power by 1. So I'm doing 2/3 minus 1. So 3 over 3 works nicely. And we're left with -1/3. Same thing, you could move, we might as well just look at what else it could be, right? Why not? We also could write this, like if you didn't see it, I could write this as 16 over 3. Now, I could make it x to the positive 1/3, but I could also do the cubed root of x. I'm just showing you different ways it could be written. Okay, and we got one more. Okay, so first I'm gonna fix this guy up, right? I'll put that radical form into exponential form so that I can use the power rule, right? Square root is 1/2 power. So the derivative is equal to, sorry, kitty cat again, let's go, is equal to 1/2 times 5, right? So 5 over 2, x to the, now if I take 1/2 and decrease it by 1, right? So 1/2 minus 1, I'm going to get -1/2. So power rule. Okay, let's check out 4. Looks like straight up power rule again. So 5 times -12 is -60. Decrease the power by 1. -2 times -6 is +12. X to the -2 decreased by 1, -3. So hopefully you're getting the hang of this. Okay, next one looks like quotient rule. So again, I'll just write it out how I memorize it. And it's just a matter of exactly that, you know, just memorization. So bottom d top minus top d bottom over bottom squared. That's how I memorize it. Okay, so let's give that a try. Oops. Okay, so the change in y with respect to x, right, that's how we say that, it's just the derivative, is equal to bottom times derivative of the top minus top times derivative of the bottom. I'm running out of room. So 2x minus 5. And then all over bottom squared. Okay, there's our derivative. Again, we could, you know, FOIL that all out, or most of the time in upper level we just leave it. Okay, let's do an example of product rule. dy dx, so change in y with respect to x. Okay, remember what this one is? So this one is first, I'll just write it down, what I like to say, first times derivative of the second plus second times derivative of the first. Okay, it's just memorization. All right, so here we go. So first times derivative of the second plus second times derivative of the first. Okay, a little bit of product rule. All right, so last part of today, let's just bring back in like where I want you to write the equation of the tangent line as well. So remember, if I want you to write the equation of the tangent line, we're writing the equation of a line. So ultimately, so I'm just going to go over here off to the side. So ultimately, remember, I need a point, and I need a slope, and then I plug into my point slope formula. Okay, so let's get our point first. So we do have -1. I think we could use, we could use a calculator here if we needed to. So we need to plug in -1 up here and up here. And if we plug in -1, we wind up getting 6. Okay, now I need to find the slope. So let's find the derivative. That'll give us the slope machine. And then we'll plug in -1, which will give us the slope at that value, that instantaneous rate at that value. All right, so the derivative is equal to -60 x to the 4th plus 12x to the -3rd power, right? Decrease -2 by 1. So this is my slope machine. Let's not forget what we're doing. This will give me the slope of a tangent line at any given x value on this function. But I want it at -1. So now we'll plug in -1 oh, excuse me. Okay, and you could use your calculator for this, and we get -72. So now we just take those values and plug them in. Remember, this is your x1 and this is your y1. So y minus 6 equals my slope times x. So x minus -1 is going to become x plus 1. And that's it. That's your equation of the tangent line. Alrighty? Okay, I think we got one more. This one looks like it's got a lot going on. Same thing though, but it's just, we have to do the whole quotient rule. So we're writing the equation of a tangent line again. So as soon as we see that, writing equation of a line. Because the quotient rule goes so horizontally, the work, I think what I'm going to do is to go down here and get ready to prep for the end of the question. Right, so we need the point, and we need the slope, and then we're going to plug into point slope formula. Okay, so we were doing it at -1. So if we plug -1 back into the original, right, that original y equals equation, use your calculator, you're going to get -19 over 6, which, yeah, is not a fun number. Okay, so now let's do our quotient rule. Okay, so change in y over change in x. So this is bottom d top minus top d bottom over bottom squared. All right, so here we go. Bottom d top, derivative of the top. Okay, so bottom d top minus top d bottom all over bottom squared. Okay, and now this is my slope machine. This whole big crazy mess is my slope machine. This will allow me to find the slope of a tangent line to this guy here at any given x value. So I want you to find it at -1. So now we have to take -1 and you have to place it in every single place you see an x. Okay, so yeah, I know it's annoying. So I'll just tell you what it is. If you do that, you wind up with 263 over 36. So now let's go down and use that as my slope. Right there, and now just replace it. And don't forget, this is your x1 and your y1. Okay, so y minus -19/6, so plus 19 over 6 equals my slope and x minus -1, so x plus 1. Okay, and there we go. That's it. All right, so hopefully that lesson went well there for you. You can always rewind, play again. Remember, this is all important stuff, you know, for anybody going into AP Calc next year, or if you take any of this in college. That's why I wanted to keep teaching it to you. All right, guys, have a good day. Bye.